All right, so I think you guys figured out that you're going to multiply that row 2 by -1, right? So that when you add these two rows together, you end up getting a 0. Okay, so you're going to multiply row 2 by -1, and then you're going to add it to row 1. So when we do that, the row 2 is now the same thing that it was before. We're not adjusting that at all. We're trying to change the first row and third row. Okay, so when I do -1 times row 2 plus row 1, all of the work you've done so far will be fine. Like this will still be a 1, this will now be a 0, okay? So you're really only worried about these two things. Okay, so when I do -1 times 0, I get 0, and I add it to 1, and I get 1 here. And then I do -1 times 4, and I get -4, and I add it to 3, so I get -1. Okay, did you guys get that for your first row? Good. Okay. All right, and then the next one, I want to use row 2 again, and I want to add it to row 3. Well, what do I need row 2 to be multiplied? So when I add it to this, it goes away. It becomes 0. -6, exactly. So I'm going to have -6 there. All right, so when I do that, all of my progress so far will still be kept, right? So I'm going to have a 0 and a 0 like I want. So I really only have to worry about these two spots. Okay, so I'm going to have -6 times row 2 is going to be 0, so -6 times 0 is 0. Added to 5 is 5. -6 times 4 is -24. Added to 20 should be -4. So Natalie, I think you had +4, so check that. All right, now at this point, really it's kind of in triangular form, like you could solve from here, but we like to try to get it to be the 1, 0, 0, 0, 1, 0. And that will be useful when we talk about inverses, which we're going to eventually, next section. Because some of you guys have asked, like, well, we know how to find an inverse of a 2 by 2, but how about a 3 by 3 or a 4 by 4? You would use this method to find an inverse. Okay, so our next step is we want this to be a 1. So we're going to divide that whole row by 5. Okay, so we're dividing this whole row by 5. So maybe I'll write row 3 divided by 5. All right, so I still have 1, 0, 1, -1. I have 0, 1, 0, 4. And I'm going to have 0, 0, 1, the lovely -4/5. That's what I was saying. I always try to make these nice, and sometimes they're just not. I mess up on a negative or something. All right. So here we go. Last step. There's only one operation that we need to do. What do we need to change? Yeah?
The top right one.
The top right one needs to become a 0, right? We want that to be a 0. Okay, so in order to do that, we're going to use that third row. So we're going to say row 3 times something added to row 1. What do I multiply row 3 by? -1. Good. You guys are getting good at this. It's a tough thing. It's pretty hard. All right, so those bottom two rows are exactly the same because they're what we want. Do you guys see how they're already in that like identity form? Okay, and those first two numbers will be the same. I'm still going to have 1 and 0 on the top. So the last two are the ones we need to find. So I do get a 0 like I wanted, right? Because I do -1 times 1 is -1, added to 1. The next one is -4/5 times -1 is 4/5, added to -1. So if you have 4/5 added to -1, what do I get? Close. It's 4/5 minus 5/5, -1/5, right? Does that make sense? So that means our answers are x equals -1/5, y equals 4, z equals -4/5. And we're done. Okay. You got it? Good. All right, now matrices aren't always this hard, right? So I've taught you how to use your calculator before with matrices, so we're going to kind of review the calculator stuff too. And that way you can always check your answers as well. So it says solve the system using Gaussian elimination or using row-reduced echelon form on a graphing calculator. Okay, so there are ways to solve on a graphing calculator that you guys have learned before. And I'll kind of review that really quickly with you. So one thing that we learned before was how to do an inverse matrix, right? So we would put this matrix in as 1, -2, -1. So basically we would have A, don't write out any of this, but I'll kind of review what we did last year. 1, -2, -1, 2, 2, -1, -1, -1, 2. And then X was our not coefficients, our variables. x, y, and z. And then b was our constant, 6, 1, 1. Do you guys remember doing that? And what we would do is we would put an A in our matrix, we put in B in our matrix on our calculator, and then we would find A inverse times B. Do you guys remember doing that whole process? Okay, so you can solve it that way. If you remember that, you are more than welcome to solve things that way. But what we're going to do is we're going to put in this whole like adjoined matrix, like we did with Gaussian elimination. So we're going to put in 1, -2, -1, 6, 2, 2, -1, 1, -1, -1, 2, 1. And on the calculator, you're not going to see this little vertical line thing.
So you do it left 3 by 4 then?
Yeah, so there's 3 rows and 4 columns. Good job, yeah.
So smart.
All right, so on your calculator, there's a button that says matrix. So we do second matrix, and we go over to edit, and we want to edit matrix A. So hit enter. And as Yaya just said, it's a 3 by 4. Oh, have you not done this before? So matrix is like where x to the -1 is. So do second x to the -1. And arrow over to edit. And if you put the 3 by 4 in correctly, it's going to look like a 3 by 4 matrix. Like there's going to be spots for all of those. And then you can just quickly put in the numbers. So you can do 1, enter, -2, enter, -1, enter, 6, enter. And then it goes to the second row. 2, enter, 2, enter, and just keep putting those numbers in. All right, do we all have it all filled in? All right. So when we do that, we're going to do second quit. And we go back into matrix, so second matrix. And we go over to math. And there's lots of things. It can find determinants for you. Now, determinants you can only find for a square matrix, so this one wouldn't have a determinant. But it finds lots of things for you. And we're going to go all the way down to row reduced echelon form, RREF. Do you guys see it? RREF. It stands for row reduced echelon form. That's what it means to have it all the way down with the identity there. So hit enter. And we want to do that for matrix A. So we do second matrix, go over to, well, I guess stay on names and hit enter. So it's saying row reduced echelon form for matrix A. And then hit enter.
Another parenthesis.
You can do the other parenthesis, you don't need it though.
Wait, how do we get to the RR?
It's under, so you do second matrix, you go over to math, and you keep arrowing down until you see RREF. So we put this in for A, and then we did RREF of matrix A. And when we did that, it gave us our answer. Isn't that so nice? Look at it. It tells us what we should have at the end of Gaussian elimination.
So that's the answer?
That is. So it's 1, 0, 0, and then what was it, 3? What were the 3 numbers? So 3, -2, and 1. So x equals 3, y equals -2, z equals 1. Now, do you think I'm going to let you use that all the time on your test?
Oh, yeah.
Wouldn't that be nice?
All calculated portion.
Uh-huh. All right, let's do one more. We don't have to do all these, but let's do one more. Yeah, it's not alpha A, it's matrix A. Sorry. All right, so we're going to go back in. Let's put this one in for matrix B so we have the other one still in there. It doesn't matter. So we're going to go over to edit, and we're going to edit matrix B this time. And B is going to be a 3 by 4. 3 rows, 4 columns. And we put the numbers in. Now be careful. What is the top row for this one? Yeah, there's a 0. So what do I write for the top row then? Wait, just 0? What are the numbers that go on the top? 5, enter. 2, enter. 0, enter. Do you guys see how there has to be a 0 because there's no z term? And then 4, enter. Oops, I messed that up. 0, enter. 4, enter. So you have to put a 0 in because there is no z term. So be very careful. It's x, y, z. All right, so then do the next row. So we have 3, enter, 4, enter, 2, enter, 6, enter, 7, enter, 3, enter, 4, enter, 29, enter. Okay, you guys got it all in? All right, do you need a calculator? So if you don't have a calculator, I have one on my desk you guys can grab. So do second quit, and we go through the same process. So we do second matrix. We want to use one of the math operations. So go over to math, go all the way down to row reduced echelon form. And then we do matrix B. So go back into matrix. Don't just do alpha B. So matrix B like that.
Wait, are we doing this on number 2?
And enter. Yep. And it gives us to us. So our x is going to be 2, our y is going to be -3, our z is going to be 6. Does that make sense? Even easier than what you guys learned last year, right? It's pretty simple. All right, you guys can go on your break.